Hello, and this is chapter 15. So, we are now talking about weathering and mass movement. So, the first part of this section about the lithosphere, right, was how rocks and the earth are built or created and grow, and how mountains are built and how forms are built. Now we're going to talk about the other half of that and how rocks and mountains and things are worn down and broken down over time. We talked a teeny bit about that with soil formation, but now we're going to get into some of the nitty gritty. Okay, so the first thing we're going to talk about, weathering and mass movement, is kind of a neat real life example, and that's Mount Rushmore. So Mount Rushmore is that famous sculpture, right, in the Dakotas, where they carved a whole side of a mountain to look like, Thomas Jefferson, Washington, Theodore Roosevelt, Abraham Lincoln. Now, as we'll learn, the more surface an area has, the more weathering can happen to it. And so, because you take this mountain and you carve all these faces into it, there's a lot more weathering. And weathering, in case you're not sure, is just the rocks breaking down into smaller rocks. So you don't want your, national monument to your four greatest presidents just, wearing away. So scientists have actually worked on these sculptures. Some parts of the faces are more stable than others, and they actually use those as support for the other parts. So right here is a close-up view. You can see, this is a worker right here. This is the nose of Washington. You can see the crack. This part is weaker, so it's weathering. And this is a stronger piece of rock. So they've actually used this as an anchor. And they do maintenance. And one thing they'll do is they'll go in there and they'll drill big, huge bolts through the rock to kind of like strengthen it. They might even use concrete like a patch. So, kind of interesting. But let's get into weathering, right? So, weathering and erosion are very similar, and some people get confused. But weathering is the part where a big solid rock is either dissolved or broken into smaller rocks, so gravel or clasts, and then dust and dirt, right? A lot of people confuse that with erosion, which is when this broken down material is moved. So mountains are weathered and then rivers erode that rock or dirt and bring it away, or ice or air, but they're two different things. We're going to focus on weathering for this chapter. Erosion is coming up in a few chapters, right? But this whole process of weathering, breaking apart big rocks into small rocks, erosion, moving these rocks around, is denudation. Generally speaking, the Earth's surface is either being built up or lowered or denuded. So there's two types of weathering. Let's talk about the first one, physical weathering. Something physically happens to a rock to break it into smaller rocks. So you have a big, huge rock, and it falls off the side of a mountain, and when it hits the ground, it cracks in half. Now you've got two rocks. Both rocks are exactly the same material, just smaller. So that's the difference. We'll talk about the other type of weathering. That changes the physical content. This physical weathering just makes them smaller. And the technical term is clast. Okay? So this happens most often at high elevations, because rocks can fall farther if they're higher up, and high latitudes, which means further north. Okay? Now, rocks, and you've probably seen this, many rocks have little cracks in them, little kind of gaps, and that is more surface area. And physical weathering acts on surface areas. Rocks don't rot, so they can't physically weather from the middle. They have to physically weather from the outside edges. And if a thing has more edges, there's more area to weather. Okay? When we look at outcrops of rocks, so bedrock that sticks up above the dirt, almost all of them have joints of some sort. Here in Zion National Park, you can see these are just little joints or cracks and the layers of rock between them. So this is just more area for the rocks to break. Okay? So one of the first types of physical weathering is what we call release joining. A lot of these rocks that we talked about are formed deep under the earth. Sometimes granite cools maybe 30, 40 miles down. There's a lot of weight on top of the rocks. They're squeezed and compressed. And if something happens, erosion wears away the surface, or the crusts fold and make mountains, if that rock moves to the surface and there's less weight on top, then the rocks can actually, almost like a sponge, expand. So what happens is when they expand, they can actually be little like cracks between the layers. Okay? And these are more joints, and again, more joints cause more weathering. This happens mainly in igneous and metamorphic rocks just because they are usually formed so deep in the earth, right? Sedimentary rocks happen at the surface. They're never under as much pressure usually. Okay? And then when that happens, excuse me here, when that happens, one of the more interesting things is you get what's called exfoliation. And this is the type of pressure release where the rock looks like literally sheets or slabs that are just kind of sliding off the side of a hill, almost like if you exfoliate your skin. Okay, so let me get to the picture. It's kind of interesting. Here's a large area of rock that kind of is like a dome, and the rock is just basically sheeting off, sliding down to the edge. Another one is frost wedging. Okay, and frost wedging is just that. Water gets in between little cracks in the rock, and as we've talked about, when water freezes, it expands. So if a little tiny bit of water is between the rock and a crack, very, very narrow crack, and it gets wet, it expands just a little bit. And this happens. And when that happens over and over, every year, a little more freeze thaw, freeze thaw, freeze thaw, it actually can eventually crack a rock apart. It's not the same thing as a pothole, but it's the same process as a pothole. A pothole isn't a layer of rock. What happens in a pothole is during the winter, the water in the ground freezes, which causes like a big, huge bubble, and the road kind of pops up over it. In the spring, when the ground thaws out and that little bubble of ice melts, it's a big empty pocket under the surface of the road, and it just kind of collapses. But same idea, this gentle movement of frost year and year. So for this to happen, obviously you have to have two things. You have to have temperatures that go below freezing. And so this is why you'll never see frost wedging at the equator, right? Because liquid, even though it's a small amount, when water freezes, it expands by 10%. That may not be in a little bit, but if you have a large rock with tons of small cracks, it can actually do this over time. Literally just break it apart. So over time, many, many years of this freeze-thaw process. Salt and root wedging are the same idea, but different mechanisms. So salt crystals. If you have salt water, right? Or let me go back on that. Salt, when it's dry as a rock, can actually absorb water. And so what happens is a dry crystal of salt, when it gets wet, like a sponge, will expand. It actually lets the water into it. So if you have salt crystals on the rock, or rock that has salt running through it and water gets into that, it literally just busts it apart. Okay? Now this happens in arid climates because if there's a lot of water present, then the salt is usually, this happens and all the salt is washed out. So for salt to remain, it has to be an area that doesn't have much moisture to begin with. And also in coastal areas because you're near seawater. So a big, huge wave from the ocean can wash on shore and it dries, and when it dries, it leaves that salt behind. So this surface can also, it takes a lot of work. It doesn't happen in one day. So it's constantly wet and dry, wet and dry. When it happens, it's neat. The wedging of the salt crystals actually pops little pieces of rock off, like that. It doesn't make that noise, that's just for me. But it forms these tiny little, like, almost like little divots. I'm going to show you a picture. They're called taphoni. Now, root wedging is simply that. Roots grow between cracks and rocks for plants, trees, and as the roots grow every year and get bigger and bigger and bigger, just year after year, they blow them apart. You've probably seen something like this if you ever walk down a sidewalk and right next to a tree, the sidewalk kind of has a little bit of a hump or it's cracked next to a tree. You can see that quite a bit. But this is what taphonies look like. So the salt got on here, it got underneath the rock, and it literally just popped off the surface like that. And you'll notice here it's right on the coast of the ocean. And then this is root wedging. This is actually a bristlecone pine like we talked about. And it started off as a little baby tree, and over the years just gradually pushed these rocks apart. So that's physical weathering. The next way that things are weathered, and the only other way things are weathered, is chemical weathering. And here, the process is different. The end result is the same. A bigger rock is made into smaller rocks. But here, these are things that change in chemical weathering. Something happens on the chemical level, the molecular level. and the rock is actually changed. So when it's done, it's a different rock. So these are rocks that are dissolved over time with different chemicals. So for instance, if you take chalk, now chalk may not seem like a rock, but it technically is. It's a mineral. And if you stick it in a glass of acid, over time it will dissolve and just basically melt away. That's chemical weathering. Okay? Now, chemical and physical weathering can happen at the same time, and they can either act to speed or slow each other down. They can interact. So, for instance, physical weathering may break a rock apart into smaller pieces, and chemical weathering may make those smaller pieces dissolve faster or slower. It all depends on the situation. But the difference here is that chemical weathering happens above freezing, because in chemical weathering, usually liquid is involved. So physical weathering, we said, remember, happens in colder areas. You do the frost action usually. And this is the opposite. This happens in warm areas. Once water freezes, chemical weathering pretty much stops. And also you need ample moisture. So in a different type of area. You see this is the predominant type of weathering in the tropics, okay, or the lowlands. But here's the thing. They can work together. So here is one rock. And this rock is, what is it? 2 feet. It's 2 meters on each side. Each side is 2 meters, or 6 feet. 6 feet by 6 feet by 6 feet. So the rock is 6 meters square surface area. Okay. Now you take this rock and you break it in half this way, and this way, and this way. You take this one rock and you break it into 1, 2, 3, 4, 5, 6, 7, 8. 8 blocks. Equal volume, but now you have these original front, right? So you had this side right here. You still have that broken into 4, but now you've got a side on this side, and a side on this side, and on this side. So basically you take the surface area, you double it. And if you keep on going, you can see right here, the same volume of material, the same mass, but the surface area is now 60 square meters. And that means that you go from 6 to 60, that's 10. That means there's 10 times more areas for weathering to occur. So what are some chemical reactions? First one's carbonation. And this is just basically the fancy thing for kind of what happens in your soda pop. CO2, carbon dioxide, dissolves in water. When you put CO2 into water, it actually kind of dissolves into it. And what happens is the water is now called carbonic acid. And most carbonic acid is not going to hurt you. I mean, Coke is slightly acidic for that reason. But if you put carbonate rocks that have a lot of carbon in them, or calcium, like limestone, it will basically melt that rock. I mean, very, very slow. You're not going to see it happen. But over hundreds of millions of years, it will basically eat it away. Hydrolysis is something similar, but here it's water. So water reacts with or combines with minerals in the rocks to form new minerals. So salt. If you have salt as a solid and you put water with it, it will actually combine with the water and form salt water, which is different. The one I showed you before, those big, huge crystals in that Mexican cave, silicates do that as well. And then hydration. Sometimes rocks add water, and it's almost like a sponge. It lets them swell up. So certain clays, types of rocks, actually have small amounts of pores in them. They're very, 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 very tight, but little tiny holes, and the water makes them kind of almost expand. Okay, and then the last one, oxidation, and this obviously informs oxygen. And it says right here, oxygen atoms combine with minerals, and what does it say here? And it weakens them. Okay, so some minerals, iron's a great example. Iron as an element loves oxygen, and when they see each other, they basically bond together. And when iron and oxygen bond together, they alter each other's chemical properties, and iron oxide is what rust is. So iron, really hard metal with oxygen, forms this kind of soft, crumbly powder. And oxygen actually responds with a lot of things. Now, weathering doesn't have to happen at the same speed. Some parts may weather faster. Maybe that area is a weaker material that weathers faster. Maybe there's a little divot or a crack in the stone and there's more area. So odd things are, weathering isn't always even. Some minerals last much longer. A great example is quartz. So quartz is a very, very strong mineral, and it lasts a long time. And quartz is a component of the rock granite. It's one of the minerals within granite. It is the hardest mineral, and granite is a hard rock, but when granite weathers away, often the last thing left behind is quartz. And when that happens, when we see a large amount of quartz, that's actually sand. And we're going to talk about that in a little bit. Okay? And so what happens is you get this type of action where stronger materials are left behind, weaker resistant minerals are broken down, and that changes the landscape. So this is what quartz is. Quartz is basically the remains of granite, just all that's left. If you look at a handful of sand under a microscope, that's what it looks like. Little tiny crystals of quartz, actually. So the Sahara Desert was at one point large granite deposits of granite. And over millions of years of weathering, the quartz is what's left behind. Now, that's not to say that all sand is quartz. This is actually sand from Bermuda. And here, the largest material are seashells and parts of coral reef. So these are actually small chunks of carbium calcinate rocks that were in the reef. But when it comes to rocks, again, weathering occurs at different rates on different parts of the rock. And as we said before, the more surface there is, the more weathering will occur. So if you look at this rock, the same area here, this circle here, has less area, less surface, one, than this has two surfaces. This has 1, 2, 3. So this weathers the fastest. So rocks like these, you tend to see the corners get rounded than the edges. This is Devil's Tower. If you've never seen the movie Third Encounters with a Close Kind, great old 70s movie, this is actually a national monument. And what this is at one time, this was the middle of a volcano. And the material surrounding the volcano was much more prone to weathering and erosion than the hard magma that solidified within. So basically all of this rock here once surrounded this as a volcano, but weathered over time and broke and fell down. These are really beautiful. These are called natural arches. It looks like a bridge, but this is a natural phenomenon. And this is just different layers of rock. Some were weaker and some were stronger. And as it weathered and eroded, it basically ate out right through here. Normally what happens with these is over time, the erosion continues and this gets thinner and thinner and thinner until finally it just cracks and breaks. Here's another example. Different types of rock eroding faster. These kind of weird structures. You can see here, it's thicker. This pillar is thicker here. It gets really thin right here. And then a little thicker at the top. But you can also see the different layers. So this rock is much more resistant to weathering than this rock is. Alright, I'm going to pause the video right here. So again, we're going to come back and finish on the next video. So I'll see you all in a little bit.